Hey, it's James from Iroda, and today I want to talk about components. Now this video is a very basic overview on the different types of components that you would run into if you were doing an electronic kit, and I am going to be explaining this as if you've never have seen a component before and this might be your first electronic project. Now, I love components because this is an area where you take a bunch of different sciences like material science, physics, and engineering, and you take all this theoretical stuff and you make a component out of it, which is kind of like where all of these hard sciencey type things kind of hit the road and become something real, something that we can actually touch with our hands. Now, resistors are the most fundamental component. I mean, they're ubiquitous in all electronics. On the most basic level, they're used to reduce current flow, but depending on how they're used, they actually have a lot of different functions, and I really do want to cover this in another video because it's a really important subject, but it's not exactly something that you need to know right off the bat when you're building a well-documented kit or project. Now, the first thing you need to know is all resistors are passive, and that means that you can install them in any direction that you want. Having said that, there is one version that is possible to install backwards, but I'll get to that in a second. Now, resistors are made from lots of different materials, but the most common ones are carbon or metal film. Now, the carbon type has a tolerance of 5%, and the metal type will have a 1% tolerance typically. There's not much of a price difference these days between the two, so most people just opt to get the metal film resistors. As an added bonus, they're a little less noisy as well, and they're more temperature stable. Now, one thing you might have noticed about resistors is they have colored strips on them. Now, this is a color code, and you can read the value of them visually. And the value is in ohms. The higher the number, the more resistance it has. A common value can go from 1 ohm all the way up to 10 million ohms. To make things easier, we break down the value of resistors in ohms, kilo ohms, which are in 1,000 ohm increments, and mega ohms. Most DIY projects, you probably wouldn't be going over 10 mega ohms at any one given time. Now, the one type of resistor that you can install backwards is a resistor network, and it's actually a fairly common part. I've seen a lot of failed builds due to them being installed backwards. Now, if your project is using these, if you look at the PCB, there'll be an indication on which direction you should put that resistor network, and just keep that in mind. A lot of people make that mistake because they think resistors are passive. It doesn't really matter which way they go. They do matter when you're using a resistor network. Now that we're talking about putting things in backwards, it's a good time to talk about polarity. Now, electrical polarity is something that everybody's familiar with batteries. You'll usually see a plus and minus symbol, and you just know that the plus end is positive and the other end is negative. Now, for this video, I'm sticking with that mental picture of polarity. It's definitely more complicated, but for just talking about orientation of electronic parts, that mental image is perfect. Now, if a part has polarity to it, they'll design some type of visual cues so you'll know which way to put it in. Which I guess is a good segue to start talking about electrolytic capacitors. It's by far the most common component that deals with polarity. Now, electrolytic capacitors are those cylindrical parts that you find in every piece of electronics today. They actually have two visual features that let you determine the positive and negative legs. One is on the capacitor itself. It will have a stripe printed on the side that indicates that that's the negative side. The other indication of the negative side is it will have a shorter leg, and the positive side of the capacitor will have a longer leg. PCBs have an indication of the positive and negative side for capacitors. They'll have a plus or maybe even a negative sign silkscreen, or it might even have a side that is filled in to indicate the negative side. It's also common to have a square pad indicating that this is the positive side of the capacitor. So now moving on, I want to talk about film capacitors. Now, film capacitors are non-polar, which means that you can install them in a PCB any direction that you want to. But the one thing to know about film capacitors are some of them are actually quite heat sensitive. So when you solder them in your board, you need to be aware that, like, you know, if you're using a polystyrene type, it's very temperature sensitive and it's very easy to melt. Now, there's a lot of debate whether one type of material in film capacitors is better than another type of material. They're pretty interchangeable, but you know, I don't want to get into the internet debate like which one is better. Just know that, you know, you can kind of substitute one for another as long as it's within the same value. It just some are more accurate than others, so it kind of pushes you into a certain type of material when you're using a film capacitor. Now, another type of capacitor that you'll run into are these ceramic types. They tend to have a very high value as far as capacitance is concerned, so they're quite popular for decoupling your power from integrated circuits. And today, like, the ceramic capacitors are really high quality. In fact, a lot of designs that use surface mount technology, or SMD, they can actually just replace a lot of the film caps with ceramic today. Some of the older ceramic caps that you run into are these disc capacitors. You know, I don't really run into them so often just because newer designs just don't use them, but they do the same type of job that the newer ceramic capacitors do. And again, they're non-polar, so you don't have to worry about putting them in backwards. Okay, so let's talk about diodes. Now, diodes have a bunch of different functions. I guess most basically you can think of it as a one-way street for current to flow. It lets current flow in one direction but kind of blocks it from the other direction, and you have a lot of different applications for this. Sometimes you can control like how much current goes through, so you could use it for like a voltage regulator. They're commonly used to convert alternating current, or AC current, to DC current. Also commonly used for circuit protection, so if you accidentally plugged it in a power supply and backwards, it wouldn't actually fry the electronic device. But the thing to know about diodes is there is an indication on them on which way the current flows, and you see that indication as a black band that has been printed on the diode. So another type of diode that is extremely common is actually light emitting. So we call it an LED, or a light emitting diode. And again, it's a diode, right? But they look different because first of all, there's no black band on an LED. So the way that you can kind of think about LEDs are more like a traditional polar part, where you actually have a plus and a minus side of an LED. And the way that you can tell on an LED which side is which is, again, by looking at the legs. The shorter leg will be the negative side. So just like capacitors, if you take a look at the legs, the shorter side is negative, the longer side is positive. And if you look on the top of the LED, you're going to see an edge, kind of a flat edge, and that is the negative side of the LED. So when you're looking at a PCB and you're trying to figure out which side is which on an LED, it's actually pretty similar to capacitors or electrolytic capacitors. They'll typically mark it with like a plus or minus depending on which side. Also, that flat feature, they'll actually silk screen an outline of that, so it's actually really easy to tell. Another trick is some people who make PCBs will use a square pad, and the square pad will represent positive. Let's talk about transistors. Now, the good news is it's pretty easy to figure out how to install them in a printed circuit board. They actually just print that outline on a circuit board and you just match it up. Some of the older style transistors have a tab, and again, on the printed circuit board, they'll silk screen where that direction of the tab goes. Now, I should mention that transistors are all different. Even though they'll look the same, there could be wildly different specifications for them. And even sometimes what looks like a transistor isn't a transistor. It just happens to be in the same package. In fact, a common component that looks like a transistor but isn't a transistor are like these smaller power regulators. And power regulators are something that you're going to run into quite a bit. So I want to talk about the bigger ones. Okay, so power regulators kind of look like gigantic transistors in a way, but they're not. And I want us to spend a second just talking about them. So the most common ones that you will see are in this particular package. This is a TO220. And you know what they do is they'll typically be converting DC voltage to another DC voltage. So depending on how much current your project uses, they can actually get quite hot, which is why you see that big metal back. Sometimes you'll actually need to install a heatsink on that. Now they're really easy to figure out like where you need to install them on a printed circuit board, because they will print a big thick line where the back of that power regulator goes. Okay, we're almost at the end here, so let's talk about IC chips. And oh boy, there is a lot of different ICs. So what is an IC chip exactly? Well, it stands for integrated circuit. And you know, you can just think of it as like its own circuit board with components built into it that are really tiny. And they're great because they do a lot of complicated functions in a very small package. But they need to be oriented in a specific direction for them to work properly. And there's a lot of visual cues on like which direction goes where when it comes to integrated circuits. So the first main indication is a notch that has been cut into the chip or died into the chip. On some smaller chips, they don't have that notch, and you might actually just see a circular indentation. And when you see that, the circular indentation will be offset. It won't be in the center of the chip, and that is how you can tell where pin 1 or the front of the chip is. So it's good to know this. It can be a little bit confusing. Don't put your chips in wrong or backwards. They don't all break, but sometimes they break. So it's just something to be aware of. It can be a little bit confusing. So again, notch, if you see a notch, it's a front. Okay, so there is another type of chip. You know, the chips that I've been talking about called dip chips or dual inline package. And what that means is there's two sets of legs, right? But there's also something called a SIP or a single inline package. And that's an IC chip that is just long. And they're great too, because I like the fact that they don't take up a lot of PCB space. It's just like one single line, and sometimes they'll have like 6 or 8 or 10 or 12 pins. But the way that you can tell which side is front and back is they'll notch the front. And different manufacturers do it in different ways with SIPs. You know, sometimes they'll put like a little bit of an angle or corner on it. Sometimes you'll see like a little circular notch on a PCB. Always look for that square pad. Whenever you see a square pad, that typically indicates that it is pin number 1 for an IC chip. So it's a nice visual representation of, oh, okay, so you see the square pad, then you know that's where the pin 1 is. And pin 1 is always where the side where you're gonna see the notch or the little circular indentation that's offset. Now, everything I've been talking about in this video, I mean, there's a lot more information out there. And maybe later I'll make another video about the individual components and kind of do a more in-depth analysis of what the components do. This was really just a very surface level explanation of components. And, you know, really it's just I wanted to demystify all of these different things that might have came in an electronic kit that you recently got and you're really excited, but maybe slightly intimidated by like what are all of these pieces. Okay, and with that, I'll be doing some more videos soon, and I'll see you guys next time.